Find the natural domain and corresponding range of g of f of x if f of x is x squared plus 2 and g of x is negative 1 over x plus 2. So if we're starting with x, we're going to go into the function f first, and the output will be x squared plus 2. That's then going to go into g, so the output will be negative 1 over x squared plus 2. Remember, g of x is negative 1 over x plus 2, so whatever goes in ends up on the bottom of that fraction, plus 2. And we might decide to write that as g of f of x is equal to 2 take away 1 over x squared plus 2. From a domain consideration, we need to think about the denominator here. The denominator is not allowed to be 0, but x squared plus 2 can never be 0. So as far as the domain is concerned, we have no problems. We can just input all reals. But we're going to need to consider the range. So our function is 2 take away 1 over x squared plus 2. Now, x squared plus 2 is always positive, so it's 2 take away something that's positive. So the largest that this function can possibly be is 2. What's the smallest it can be? Well, if we think about the fraction, x squared plus 2 is always greater than or equal to 2. That means that the biggest this fraction can be is a half. For any other value of x, if we take x equals 3, then this fraction is 1/11. So the smallest this function can possibly be is 2 take away a half, which is 3 over 2. Therefore, the range is real values that are between 3 over 2 and 2. Not only that, but I can't actually have the inclusion at that end of the inequality, because as x gets larger and larger, 1 over x squared plus 2 will tend to 0, but it will never actually be 0. So the 2, the function cannot actually take that value. It will just tend to 2. If you like, y equals 2 would be an asymptote. So that needs to be a strictly less than.